All right, this is video number 2 of 6. This is my second example. We're going to solve something that has a rational exponent on one side. Again, my rational exponent is a fraction up in the exponent. In this case, it's the 4/3 that's sitting above the x minus 5. First step is to isolate whatever the rational exponent is around. That x minus 5 to the 4/3 is already isolated. There's no step 1 in this case. We don't have to move something that's added or subtracted or something that's multiplied or divided by the front of this. So my first step is going to be, what do I need to do to get rid of my rational exponent? My rational exponent is 4/3. We've talked about this before, how if I multiply by a reciprocal, I will end up with a 1 in the exponent. The 4's cancel and the 3's cancel. And on the left-hand side, I'm going to end up with x minus 5 to the 1, which is just x minus 5. Whatever I do to one side, I have to do to the other side. That 81 has an exponent of a 1 right now. So I'm going to multiply that 1 by the same thing that I multiplied the exponent on the left-hand side by, which is 3/4. So I get x minus 5 is equal to 81 to the 3/4. Think back into your notes from a few days ago where we talked about a to the m over n being equal to the nth root of a to the m. That was from 6.1. So when you see something like this on the right-hand side, I want you to think about turning that into its radical form. You won't have a calculator for this, so you need to be able to do this without your calculator, and rewriting it as the 4th root of 81 to the 3rd. And that's equal to x minus 5. Now we know the 4th root of 81 to the 3rd because we know our powers. We know that in 81, and there's a 9 and a 9, and in those 9s there's a 3 and a 3, and we're looking for 4 of things because my index is 4, so I'm going to circle my 4 3's and I get to take those out. When I pull this out, I need to just stop for a second and recognize that at this point I'm solving for x. This goes back to when we need to remember when we take the even root of something, we need to put a plus minus on the front of that. That's going to be plus minus 3. I still have the cube on the outside. So the 4th root of 81 in a solving situation is plus or minus 3 to the 3rd. When I take plus or minus 3 to the 3rd, I get plus or minus 27. So now I have x minus 5 is equal to plus or minus 27. All right, so we have x minus 5 equals plus or minus 27. So at this point, we're thinking back to a similar problem that we used to have when we solved problems where we had to take the square root of both sides and got plus minus. I need to consider that this is going to have two different solutions. It's going to have x minus 5 equals positive 27, and it's going to have x minus 5 equals negative 27. So I'm going to solve both of these, and I'm going to get x equals, adding 5 to both sides, x equals 32. Adding 5 to both sides over here, I'm going to get x equals minus 22. So this has two solutions. And again, like our last problem, you can check these in the original. If I put this back up in the original equation, I would get 32 minus 5 to the 4/3. That gives me the 3rd root of 27 to the 4th, which is 3 to the 4th, which is 81. So 81 equals 81, that checks. I have minus 22 in for x. I get minus 27 to the 4/3. I can take the 3rd root of a negative number, so the 3rd root of negative 27 is negative 3, and negative 3 to the 4th power gives me positive 81. So whenever we take the even root, like we did right here, we need to be sure we put on plus minus onto our answer. Okay? And as always, when you're done, go ahead and check your answers because there's going to be a few that come up next where the answers are going to be extraneous or false answers and they won't check. So both of these did check in the original equation.